All right, welcome back, everyone. I'm Tony DeBora, co-director of the Johns Hopkins Institute for Assured Autonomy. And before I introduce our speaker, I just want to tell you that he gave an earlier version of this talk to a group of us from the Institute, and I can tell you that you're in for a real treat. Peter Najjar is Vice President of Clinical Innovation for Johns Hopkins Health Systems, where he leads system-wide efforts to advance care delivery through novel clinical systems, data infrastructure, and technology innovation and commercialization, based out of the Armstrong Institute for Patient Safety and Quality. He also co-directs the JHM Health Systems Management Fellowship for budding physician executives and serves on several hospital and healthcare company boards. Clinically, he teaches and practices complex and robotic colorectal surgery at the Johns Hopkins Hospital. He attended the University of California, Davis, before earning his MD from the University of Chicago and MBA from the Harvard Business School. He completed general surgery residency and fellowships in both colorectal surgery and patient safety and quality at Harvard's Brigham and Women's Hospital and Dana-Farber Cancer Institute. He's a fellow of both the American College of Surgeons and the American Society of Colon and Rectal Surgeons. Peter, welcome.
Okay, so is this thing working? Do I need to stay by the mic? Okay, good. Everybody can hear me okay? Okay, fantastic. Thank you, Tony. That was a overly generous introduction. I appreciate it. This is just a really great event, and it's really a pleasure to have the opportunity to speak with you all. I'm going to try and whiz through the content so that we can have time for kind of discussion. So would love to entertain questions and have kind of an interactive dialogue. Selfishly, that's what I get out of the presentation. So if you'd humor me on that front, I'd appreciate it. So let's see, does this clicker work? Great, ooh, these are fancy slide transitions. All right, so we're going to talk about unlocking the promise of deployed artificial intelligence for quality and safety. We'll skip the learning objectives. So these are the formal disclosures, but I think they're relatively irrelevant. It's about a latte's worth of financial conflict. But the really important things, I think, are my confessions. And so I'll just kind of set the stage for the lens that I'll be talking to you through. The first is that I'm a curious, pragmatic generalist. I don't have any technical background in computer science or math or engineering or any of the things that the vast majority of the folks in this room have. And I just listen and learn and oversee sort of the internal clinical innovation engine for quality and safety at the health system level in that way. And so I'm always very, very grateful to be well tutored by folks in the Hopkins ecosystem who know a lot more in these arenas than I do. The second is I'm a surgeon, so you'll see a lot of the examples and sort of content areas that I cover are just kind of drawn from my clinical practice. So I'm sorry for that, but also that explains why you'll be hearing a little bit about colorectal surgery today. And the third is a disclaimer, which is that I'm really excited about the future of medicine and healthcare. I had a student, a medical student actually, who turned down a job at one of the major sort of frontier labs for what I'm sure was, you know, high 6 or low 7 figures, and came here to do an MD PhD. And I asked them, why did you do that? You know, why did you make a decision like that? And what they told me was that they felt that we are at the dawn of a golden age in sort of medicine and computational biology that is akin to the advent of the microprocessor in the 1970s in computer science and technology. And I thought that was a very, very sort of compelling lens, and that stuck with me. And so I really do think that this technology has the power to be deeply transformational, both for our field and more importantly for our patients and their families and society at large. So that is a bias, a disclaimer that I'll leave you with. So what are we going to talk about today? We'll spend a little bit of time on the promise of this technology as I see it. We'll talk a little bit about this concept of sort of data and data fusion as a key animator of that promise and what that means for us as an organization here at Hopkins. And we'll talk a little bit about the practical implications for clinical operations. And I'll try to get through this about what it looks like I have 38 minutes. Okay. So the promise. So a couple of observations. We live in this strange sort of paradoxical universe right now. On the left-hand side of the screen, I'm going to talk to you a little bit about the incredible advances in medical science that have occurred over the past 20 years or so, and they're really astounding. So a couple of examples. The first solid organ oncology trial that led to a 100% remission rate. We've been doing cancer studies for decades, and oftentimes we're looking for, small survival improvements. We come up with these really sort of esoteric ways to measure lack of tumor growth, right, in order to see if one particular chemotherapy regimen is better than the other. And the first solid organ tumor trial that had a 100% remission rate that in follow-up studies has been durable, which means the cancer just melted away and never came back in every single study participant, was just a couple of years ago up at Memorial Sloan Kettering. And it was actually using immunotherapy techniques that were developed here at Hopkins. They beat us to the trial, but we'll forgive them for that. And it was a small study. It was less than 20 patients. But it basically sort of realized this reality that surgical oncologists like me have been saying for decades. Well, eventually, when we figure out how to treat these, cancers most appropriately, it's going to kind of obviate the need for surgery. And that's a really violent way to treat a cancer, to go in there and physically cut it out. And here we are, and it's happening, and so there are patients today that I see in my clinic that historically would have undergone 6 months of chemotherapy and radiation therapy, followed by an incredibly morbid operation that would take about 4 or 5 hours with a week-long hospital stay. And now they get an infusion of immunotherapy that has a very, very low side effect profile once a week for a couple of months, and the tumor just disappears. I mean, it's bordering on miraculous. Short of those kinds of individual massive advances, things like cystic fibrosis treatment and, the ability to eradicate certain types of hepatitis, you also see myriad sort of small technical improvements that all aggregate to lead to these massive improvements in outcomes as well. So when we look at colorectal cancer mortality broadly, we see that these Kaplan-Meier survival curves start to deviate from one another. And the most incredible thing about this chart is that they deviate in 2 to 3 year increments. And so what that means is that if you were diagnosed with a colorectal cancer in 2015, and you compare that to being diagnosed with a colorectal cancer in 2017, you have a materially improved long-term survival after just 2 or 3 years. And so these epochs are getting shorter and more condensed, and we're getting better and better at delivering care. And you also see this across the entire population when you take screening into account. So even pre-diagnosis, we're better at making screening technology more available with stool studies, DNA testing, and improved access to colonoscopy, et cetera, et cetera. And you see colorectal cancer mortality declines across the board, with the exception of the young, and we don't fully understand that yet, but it's probably an environmental determinant. So you see these massive advances in the medical science, and yet we still struggle with the delivery of care. And so the quote at the top here is a good friend and a surgeon who has been working at the American College of Surgeons doing quality work for decades now. And he writes that suboptimal care is a much less tractable problem than perhaps was anticipated at the dawn of the quality and safety movement. It's now clear that QI itself requires improvement. And so you'll see these stubborn gaps in care. So we're getting better at treating colorectal cancer, and yet postoperative compartment syndromes, which are these devastating complications that are the result of prolonged pressure during robotic surgery, are arising. And when we zoom out and we look at sort of adverse events across the board, this is a great study at about 10 hospitals in Massachusetts, looking at about 3,000 admissions. And they found that 7% of those admissions had a preventable adverse event, and a serious preventable adverse event in 1%. And those numbers seem stubbornly persistent over time. And so we're faced with this paradox where the medical science is improving at this incredibly dramatic rate. And yet, if you define quality and safety as the gap between what medical science allows and what we are actually able to deliver to our patients day in, day out, that gap not only persists, but it's probably actually getting bigger. And so that is a very, very kind of stubborn and challenging state of affairs. And for somebody like me who sits and thinks about how we get that gap to narrow instead of expand, I think it's really, really important before we dive into the technology to understand why that gap exists and why it's getting larger. And so we'll talk a little bit about sort of, why we are struggling with the delivery of what are unarguably incredible advances in medical scientific capabilities. The first is the perpetual increase in clinical complexity. Patients are getting more complicated, and care is getting more complicated pretty much every way you measure it. This is a paper that was written almost a decade ago now, but was really prescient. It was a colleague of mine actually up in Boston, Ziad Obermeyer, and he writes that the complexity of medicine now exceeds the capacity of the human mind. Computers are the solution, but using them to manage this complexity will require fundamental changes in the way we think about thinking and in the structure of medical education and research. It's a very prescient article that was written almost a decade ago now, before the dawn of sort of generative AI and large language models. And on the right side there, you'll see a graph of new controlled trials published annually. And that ends in 2010. And you can see it's essentially asymptotic, and that slope is getting steeper and steeper. And we've tried to solve for this with things like increasing subspecialization. 2 decades ago, there wasn't really such a thing as a colorectal surgeon. It was like, what, you need to go to additional training to learn how to take out a colon? I mean, that's just general surgery. And what I tell people is I don't worry about my graduating chief resident's ability to do a 1990s colectomy. I worry about their ability to do a 2025 colectomy, which entails being able to do it open, robotically, laparoscopically, being familiar with advanced endoscopic imaging like laser confocal endomicroscopy with advanced endoscopic therapies, with a growing body of evidence around molecular diagnostics around the tumor. Should you even be in the operating room, or does this patient qualify for immunotherapy? And so the complexity is just skyrocketing. Patient complexity, patients are older, more comorbid conditions, and the number of treatment options are just exploding. And it's absolutely impossible to keep up, even for the most narrowly specialized subspecialists. And this is almost a welcome challenge, but it is a secular trend that is not reversing itself. In fact, it's accelerating. And so that perpetual increase in complexity is really straining human cognition and straining our system's abilities. The second is consolidation and network growth. And this is a chart that shows hospitals that are in a health system in blue and hospitals that are freestanding, independent, not in the health system in orange, from the Kaiser Family Foundation. And the astute observer will note that the absolute slopes are not equal. And that's because not only are independent hospitals merging and becoming part of hospital chains, but they're also closing down. And so we are faced with this scenario in which, the old way of doing quality and safety is, well, you trained the docs that you're hiring, and you train all the nurses yourself, and you manage quality and safety by walking around. You go down to the operating room and you say, I don't like the way that you're sewing there, turn your body. And when you're part of a large integrated healthcare system with 6 to 106 hospitals, all across the country, and in many instances globally, that old way of managing quality and safety just doesn't work anymore. You can't manage by walking around. It's become incredibly complex. And our information systems and the ability to sort of really understand the processes of care that are occurring in geographically disparate locations has simply not kept up. And so this consolidation and network growth, which was purported to result in sort of economies of scale that were going to allow us to be more efficient and provide higher quality of care and improve access, unfortunately, the literature is fairly clear that we have not seen those improvements. We've seen the ability to command higher pricing because we can negotiate more effectively with commercial insurers, but we have not seen sort of the promised improvements in quality and safety and clinical outcomes that result from the ability to pool resources and operate at scale. And the third is staffing and productivity trends. So there's a global shortage of skilled labor in healthcare, and it was accelerated certainly by the pandemic, and this is another secular trend that shows no sign of abating. And just to emphasize the importance of sort of skilled labor and institutional memory, this is a great paper out of the American Economic Journal that shows the length of stay and likelihood of readmission stratified by the tenure of the discharging nurse. And you can see that a more experienced nurse discharging you from a hospital means that you're likely to go home sooner and that you're less likely to have to come back. And in an era in which average nursing tenures, to take a specific example, are dropping precipitously, they're oftentimes less than 2 years in many healthcare systems. Does this pointer work? Let's see. Oh, very cool. 2 years is right around here. And average tenures now are dropping below 2 years in a lot of our systems. And so you can see the loss of this institutional memory. Gone are the days of the scrub tech with 30 years of experience that used to tell me when I was a trainee, this is the type of suture that Dr. So-and-so likes to use. And so we're losing that institutional memory. And that knowledge, that tacit knowledge, is not codified in our policies and operating manuals and procedures. And you also have that happening at the same time that we are part of large integrated systems and the complexity is increasing. And so the sort of summative effect of these three secular trends makes it incredibly challenging and requires that we look for sort of paradigm shifting approaches to solving for these problems. And the last piece of evidence that I'll share with you is this really sort of fascinating state of affairs, which is that in pretty much every other American industry where we measure labor productivity, which is sort of amount of output per human labor hour put into a system, we see improvements in labor productivity. You have more hotel rooms to stay in per unit of labor. There are more flat screen TVs that come off of an assembly line per hour of human labor that put in, with a glaring exception: healthcare. Healthcare is one of the only industries in the United States that has seen not only flat but negative labor productivity over the past decade. And I can tell you, I also see that anecdotally. I cannot produce more colectomies today than I could 15, 20 years ago. In fact, I likely produce less. I have to use a $2.5 million robot now that requires specially trained staff in the room that we didn't used to have. And cases take longer and they're more complicated. And so we have this sort of negative labor productivity trend here that we're also tackling. So we're faced with all these challenges, and what's the solution? If you'll permit me to daydream a little bit, I think it's a useful exercise to sort of start at what the utopian ideal would be, and then break that down in a really pragmatic way to figure out, all right, what do we do tomorrow to work towards that? So, the ultimate goal here is probably something like this. So show of hands, people who know this character. I know Andrew Menard here in the front row does. Okay, this is the best audience capture rate for the emergency medical call. So usually I get either no one raising their hand or maybe one or two people raising their hands. So it's great that we've got maybe like 30% of the audience here that recognizes this character. So this is the Doctor from Star Trek Voyager. And this is a spin-off of what I think is the best Star Trek series, The Next Generation. And the plot is that Star Trek Voyager was this exploratory vessel. It gets sucked into a wormhole and deposited in some distant, I think it was the Gamma Quadrant. Delta Quadrant, thank you. And is just unable to make it home even at maximum warp. And so the series is just trials and tribulations of this kind of isolated ship kind of trying to make their way back home. And every third or fourth episode, there's some sort of medical emergency, some alien virus that infects the crew or some sort of traumatic medical event. And there's no physician on board, but what there is this emergency medical hologram. And this emergency medical hologram is basically an embodied AI, and he appears, and he's known as the Doctor, and he basically can order a battery of diagnostic testing, imaging, tricorder results, et cetera, interpret all of that, and is also familiar with the entirety of published human and alien medical literature and can cross-reference it, and comes up with treatment recommendations, diagnostic and treatment recommendations that then the staff can kind of help him enact. And he's, it's interesting that, even in this sort of idealized, utopian future state about 350, 400 years into the future, this AI remains as an assistive technology. It's still the humans who kind of make the final decisions in accordance with their values. And he's also a little bit annoying, which is kind of, I think, reminiscent of health technology today, right? He's like a little bit difficult to work with and, a little bit arrogant and kind of thinks he knows better. But isn't this kind of what we're building towards, right? This AI that can appear anytime we need it to and is able to interpret all of the medical information that we've got, cross-reference it with all the available literature, and then help us achieve sort of the optimal outcome for the patient. And what's really incredible to me is that if you had asked me, when I was watching the show growing up, or even 5 years ago, I would have said, I don't know when this is going to happen, but probably not within my lifetime. And now, in a lot of ways, I think we can all confidently say that it is definitely not going to take us 350 years to get here. And that is really sort of dramatic and exciting. But it also means that we've got our work cut out for us, because this technology is here in a lot of ways, and so we have to think about what are the pragmatic steps that we need to take to be able to deploy it, study it, and take advantage of it. And a few months ago, this kind of critical threshold was crossed, which is now every paper that I read that looks at the deployment of generative AI across various medical benchmarks. And there are problems with each of them, and we could talk about the limitations of benchmarks to measure real-world performance, et cetera, but they all pretty much now show that AI is crossing the threshold at which it performs better than human physicians at equivalent tasks. And that's a really kind of stunning state of affairs, and it's happened very, very quickly. And so I would argue that creates now an ethical requirement, a moral requirement on us to be able to get this technology out and into the real world to be able to drive the improvements in outcomes that it promises. So working backwards from this kind of pie in the sky, exciting future state, I'm thinking about what are the practical sort of foundational elements of work that we need to do to realize these advances. We'll talk a little bit about clinical AI for proctologists like me. And I apologize for having to dumb it down to this level, but it's the only way that I can really understand this stuff. And so as I think about what it is that we do as providers, a couple miles in that direction, when we provide care to patients, and what it means, people like to talk about value in healthcare, what's the core of what we do? And the most simplistic way that I can define it is that when we provide care for patients, what we're really doing is predicting and modifying future health states, right? And you can sort of think about the prediction as the diagnosis and the modification as the treatment, but that's really kind of the ideal state. If we can accurately predict what the natural course of a particular disease is, and we have a mechanism to modify that natural course to a more favorable future state, and if we can deliver that modification efficiently, right, then we're winning the game. And as we think about what it takes to improve care, right, to decrease that delta between what medical science tells us is possible and what we are actually able to deliver to our patient every day, that gap that is increasing over time, then what we're really talking about doing is improving our ability to predict, and I'll call that actuarial, and improving our ability to efficiently modify, and I'll call that kind of operational. And so this is really the core of what we're tasked with doing in healthcare delivery. And if we then step back from that and think about, okay, what are the capabilities that we need to measure and modify actuarial and operational risk to get those improvements, then it broadly falls into three buckets. The first is that we need to exponentially expand data collection. The sort of dawn of sophisticated learning has necessitated enormous amounts of really high quality data that in many cases don't exist and haven't been appropriately aggregated in healthcare because we haven't really had any use for them, right? If you just charge kind of a monthly fee and it's all you can eat at the buffet, then you don't invest in a barcode scanner to do itemized checkout because there's not really any utility for those data. Well, now there is. And so we need to expand that data collection both in scale and in scope. Scale meaning, we've got to take all of the alphanumeric data that we already kind of capture and that sits kind of strewn in, up and down the eastern seaboard at Hopkins in various thumb drives and disaggregated data sets, and really start to bring them together. And there's an enormous amount of progress that's happening in this space. And in scope, we need to switch not just from alphanumeric, but to multimodal data as well. When you think about how providers actually practice medicine and do diagnostics, they don't sit at the computer and consume alphanumeric data. They go to the bedside. They perform a physical exam. They use audio and video data to make a determination as to what sort of the predicted future health state is going to be and what interventions are available to the patient. And a really interesting analogy, I think it was Jan LeCun who I heard this from, is that you think about the amount of visual data that a human child trains on in the first 4 or 5 years of life. I think it's about like 20 megabits a second, per eye. Multiply that over 4 years, and it's about a petabyte of data. And that's a couple of orders of magnitude larger than the largest training data sets for LLMs today. And so we really need to dramatically expand the types of data we collect and the amount of data. We need to cross-link it and make it available to algorithms for training and learning. The second, when we're able to do that, is to transition from, in many cases, having no data, right? So we're going to solve for problem number one, to then doing a better job at retrospective understanding of what occurred so that we can sort of delineate novel process outcome relationships. And then as quickly as possible move from, how were we doing last quarter to real time to say what's happening right now in the system, what's going on, to then moving to predictive analytics to say what is going to happen tomorrow. And then eventually to be able to say what needs to be done in order to make what is happening tomorrow more favorable. And I'll call that prescriptive analytics. And that's something that is really, really a core part of this kind of transition from kind of flying blind and not really being aware of kind of what's happening under our noses to a universe in which we can take those prescriptive analyses and then actually implement them. And that's the third point, which is to automate the implementation of those accurate prescriptive analyses at scale where possible. And as I see it, that's really the only way at 10,000 feet that we're going to be able to solve for this growing gap, to offload the complexity from human cognition, from our organizational frameworks, to be able to free up the bandwidth to be able to sort of tackle that subset of problems that we cannot fully understand and automate computationally. An enormous amount of work is going to have to go in to each of these three kind of buckets of capability. But I think that almost all of the work that I see falls into one of those buckets. And this seems to me a useful framework for sort of organizing it. And so if we step into that kind of first bucket of thinking about how do we set up and expose and organize our data in order to be able to accomplish this sort of slow march towards the emergency medical hologram, we should talk a little bit about this concept of data fusion. And a couple of examples from outside healthcare that for me were kind of eye-opening to the power of this sort of new era of really large multimodal data sets. So this was a report that was released by the Director of National Intelligence back in 2022. And it was evaluating sort of the risk of commercially available information to American consumers and American citizens. And I'll read from the report directly. And what the report says is that today, in a way, far fewer Americans seem to understand, and even fewer of them can avoid. Commercially available information includes information on nearly everyone that is of a type and level of sensitivity that historically could have been obtained, if at all, only through targeted and predicated collection. So what that means is that government agencies are now able to buy commercially available data sets legally, things like the GPS coordinates, that were where you were when you ordered the Uber, what level your battery was at, your consumer purchasing history, credit card data, et cetera, et cetera. And they can fuse those data sets, re-identify folks, and obtain insights about them and their behaviors that you would historically only have been able to obtain, if at all, by having a spy follow you around. I mean, that's chilling, but also an incredible testament to the power of fusing disparate data sets at scale and increasing the amount of data that we have available. And you can imagine being able to deliver this level of insight to individual patients as we treat them, right? And very, very simplistically, as I think about our ability to sort of predict future states, insurers are able to do this very, very well, right? When you have a population of 5 or 10 million covered lives, you're able to predict the actuarial loss curve extremely accurately 5 to 10 years out. And very, very simplistically, right, as the cohort size decreases and as the temporal horizon over which you are predicting narrows, the raw amount of information that you need mathematically stays roughly the same. What that means is that you need dramatically more information per patient, and you need dramatically more information per unit of time as you want to compress that cohort and as you want to compress that time horizon. So to go from predicting sort of what's going to happen over a population of 10, 15, 20 million people over 5 years to predicting what's going to happen to 1,000 hospitalized patients over the next week, to what's going to happen to an individual patient in an intensive care unit over the next hour. What that means is that we're going to have to dramatically increase the amount of data that we've got available per patient per unit time in order to be able to replicate this level of insight. The second example that I'll share is around 5th generation fighter jets. And in my naivete, I would have thought that the F-35 achieved aerial superiority, and it does, because of the aerodynamic characteristics of the aircraft. It can fly faster, it can take tighter turns, it can carry more heavy weaponry, maybe it has longer range. And it turns out that that's entirely wrong. The reason that these fighter jets achieve such dominant aerial superiority is because of their ability to fuse disparate sensor streams for the pilots. And so in a 4th generation fighter jet, you have an enormous amount of sensor data in front of you. You might have an infrared contact, a radar contact, transponder data. You have the rules of engagement for this particular segment of airspace, and so on and so forth. And the pilot is tasked with manually synthesizing all of that information to be able to delineate what to do with a specific piece of information. And then once they've synthesized all that information and kind of come to a determination, then they have to engage in their tactical planning and execution of that tactical plan. And what the F-35 does is it actually takes all of that data and fuses it into a single view of the battle space that's then projected as a heads-up display on the visor of the pilot's helmet. And so now, rather than having to individually interpret an infrared signature and a radar contact and transponder data, you'll have a fused view that tells you that this is an enemy MiG and it is flying away from you at this speed, and these are the rules of engagement in this particular area of the theater. And now all of the bandwidth that the pilot used to have to put into delineating what was going on is redirected to tactical decision-making around how to respond. And that's just an incredibly powerful technology that allows that pilot to operate at the top of their license, as they say, and really deploy their cognitive bandwidth in meaningful ways to kind of address what's happening in front of them. And so as we think about data fusion in healthcare today, we've actually done, I would argue, a really good job. We've got a lot of incredibly talented people in the field, Anna Hopkins, and a lot of them in this room, who have taken an enormous amount of previously analog, non-digitized information, put it into a unified electronic health record. I mean, when I was in training, which is not that long ago, I used to have to walk around for 2 to 3 hours a night as a surgical intern and manually collect vital signs from pieces of napkin and paper charts at patients' doors. And then we would put all that together so that at 6 a.m. rounds, we had a set of vital signs that were 6 to 8 hours delayed, but at least that we could kind of, make decisions on. And now we've taken all that information, we put into the electronic health record, and that's allowed for an enormous amount of research and improvement, because we've been able to sort of understand the full cycle of care in the alphanumeric data that we've been able to aggregate there. And we do post-hoc analytics to learn and provide these improvements. And the future state is that we need to sensorize and capture much, much more information at the individual medical encounter, and that includes physiologic data, device settings, audio, video, et cetera, process it, automate as much as we can, put it into the electronic health record, and then do post-hoc analytics on that enriched multimodal cross-linked data set, that fused data set, to enable improved post-hoc analytics, but also eventually real-time intervention. And that's moving from that sort of retrospective to real-time to predictive to prescriptive sort of posture around understanding what's going to happen in our health system and at the individual patient level. And you're seeing examples in which we're already doing this, and there's more of them than I can talk about, and obviously there's just so much going on in this kind of explosion of AI deployments. But to take a really simple one, for example, AI scribing, I mean, that fits into this paradigm very nicely. We sensorize the clinical encounter with a microphone. We have an audio stream that we historically did not have. And we are able to transcribe that, process it, and generate a draft progress note or history and physical. And that speeds our ability to document and bill and provide patient care, and allows the physician to focus on talking to the patient instead of documenting in the real, in the moment, in the clinic. And so as we think about sort of implications for moving forward, last step out of the sort of healthcare space, but Chick-fil-A, I think, is a really instructive example of this. Chick-fil-A, for those of you who don't know, I mean, the sandwiches are delicious, but they also are extremely high performers across pretty much every domain. Their profit per square foot is one of the highest in the industry. Their net promoter scores, customer satisfaction, is among the highest in the industry. And their employee satisfaction and retention is also among the highest in the industry. And at peak hour at a Chick-fil-A, you've got to get a sandwich out every 16 seconds, a order of waffle fries every 14 seconds, a car through the drive-thru every 20 seconds, 270 total transactions. And the old way of sort of managing this when it came to chicken tenders was that you took the chicken tenders out of the oven, and then there was a certain amount of time that could elapse under the heat lamp before sort of food safety concerns arose and the chicken tenders got stale and not as juicy and delicious. And there used to be a manual timer that the staff would have to press. And the Chick-fil-A technical team is incredibly sophisticated. They deploy bare metal Kubernetes at individual sites and have an incredibly sophisticated system to track this. And so what they did was they put a camera over the heat lamp and a barcode on the chicken nugget tray. And so now folks can pull the chicken nuggets out of the fryer and put it under the heat lamp, and the system automatically recognizes that there's a fresh tray of nuggets. It can count the individual nuggets, automatically sets a timer, and when that timer elapses, it knows how many unsold nuggets were left over in the tray. And so they have an enormous amount of systemic access to data now that they can improve their supply chain and improve their sort of titration of how many chicken nuggets to fry for peak hour that maximize freshness while minimizing food waste. And when you hear Alain Nicolette, their enterprise architect, talk about this project, a couple of things are very salient. He says that the resulting principle for smart restaurant work is to make the right thing easy to do. The black box timer solution did not support that goal. It requires multiple taps by restaurant team members to start timers and an excruciating 3-second press and hold to cancel an existing timer, and it provides exactly zero systematic access to data. And the word that I want to draw everyone's attention to is this one, excruciating. This gentleman described a 3-second button press as excruciating. What that means is that he understands at a very deep level what the challenges of a frontline worker at a Chick-fil-A at peak hour really are. That 3 seconds represents something like 20% of the time it takes to get a sandwich out the door, and is a non-trivial performance metric. And I think as we think about how to develop and deploy this technology operationally, we should strive to have that level of empathy for what our frontline teams are experiencing. how we design these sorts of things. So for our sort of innovation strategy at Armstrong, I propose kind of a three-part test for new technology adoption, and you kind of have to get a perfect score. The first is, does the technology do something useful for us today? The second is, will it create or utilize infrastructure that we will be using tomorrow? And that's a test of that alignment. We can't purchase and deploy every shiny object. We have to make bets. We don't have unlimited capital. And that leads us to the third point, which is the net outlay small or negative? And that's ROI. And that time to ROI is really, really critical and informative of the types of technologies that we can deploy, because we can't make $100 million bets over 5 years that have an uncertain sort of outcome. We're economically constrained in that way. And I'm happy to talk through a couple of examples that we're doing, that are very real and present, around data scale and scope, using LLMs to reason over the chart to speed up our ability to abstract clinical concepts, and then using computer vision in our operating rooms to be able to ease documentation burden, something as simple as noting in the chart when the patient arrived in the room and triggering the automated notification to let surgical teams and anesthesia teams, et cetera, come to the room so that our nurse can be at the patient's bedside with an awake patient rather than documenting an epic. These are kind of some of the areas in which this work is really active and ongoing with, and these are two small examples amongst many with and innumerable collaborators kind of across the health system and the university. And there is just an enormous amount of opportunity across so many domains for us to merge operationally what we're looking to do today, tomorrow, and in the next year with research needs and opportunities with many of the folks in this room to develop this technology and ensure that it's safe and effective and deployable in the coming years and decades. And with that, I think I'm pretty close to time, but super appreciate everybody's attention and happy to chat for a couple minutes if we've got time for at least a question or two.
Wonderful talk. Beautiful. So on the 6.9% avoidable readmissions that you introduced in the beginning, could you just elaborate a little bit more on that? What could patient do or what could perioperative do other than the experienced nurse that you mentioned?
Yeah, so I think that's the challenge, right? It's very, very difficult to sort of understand in detail and quantify exactly what an experienced nurse does during a patient's discharge that gets them out of the hospital sooner and makes it less likely that they come back. And I think that's where the sort of deep learning, around being able to reason over these really large data sets to capture that information, to be able to understand what's really going on is really the future. Because as of now, a lot of those data just go uncaptured. And so we don't really have a way of understanding exactly how those effects manifest themselves. And I would argue that the solution is to capture more data about current state operations so that we can deepen our understanding and come up with interventions that make up for the lack of availability of a nurse with 10 years of experience to do every discharge.
Fantastic. Thank you.
Hi. So I had a question about something you said about productivity, where productivity in healthcare isn't increasing like you're seeing in other industries. So one of the big differences there is if you generate more time or capacity in healthcare, we want to shift that to improving outcomes, right? So I might want to make more TVs on the same production line faster. But if you tell me I can save 10% of your time making a TV, I would say, okay, well, how do we make the TV better, right? Because we always want to improve outcomes. So is that what's going on, or it's no, outcomes are pretty much the same and productivity isn't increasing?
So the first, the caveat is that we could probably talk for 2 hours about how we measure, right, output in healthcare. And so that's kind of like an anecdotal example, and I think we can get into the weeds there. And I know that there's at least a couple of economists in the room that would probably enjoy that debate. But I think that at 10,000 feet, for the purposes of this concept, it's probably both, right? So we know that we are capacity constrained in healthcare. We have access problems, and those access problems are just not solvable by increasing the human training pipelines. It takes too long, and there aren't enough people, and it's too expensive. And superimposed on that, we have a persistent gap between outcomes that are possible and outcomes that are delivered, and that gap is growing. That's not to say, and this is really a critical nuance, right? That's not to say that we are not getting better in an absolute sense. That's why I shared with you those outcomes, that clinical outcomes are getting better over time. I would rather get diagnosed with a colorectal cancer today than 5 or 10 years ago. But the gap between what is possible is getting larger because the medical science is increasing at an exponential pace, and our operational improvement is increasing linearly. So it's not a trade-off. It's both of those things. It's challenges with access and challenges with quality as defined by the gap between what's delivered and what's possible. Does that answer the question?
Yes, thank you.
I guess I always see this like kind of arrow drawn from value-based care to incentivizing quality improvement. And then people have this theory that will lead to, more AI adoption. But from your vantage point, I'm curious, what do you think the current incentives are? If you could talk about that for a second, how strong are they and where do you see that going in the coming decade or so?
Yeah, so I think it's one person's opinion. So I think that there's a lot in that question. So there's a cottage industry of folks kind of demonstrating that providers respond to financial incentives. And you will find good studies that show that on the margins, we'll do things like more carotid endarterectomies to prevent strokes in a fee-for-service system than in a salaried system. And I think that misses the broader point. The broader point is that most people go to work in healthcare every day and they do the right thing for the patient in the face of perverse incentives. And so this movement to sort of address the incentives in an attempt to drive improvements in care, I think was well-intentioned but missed the fundamental limiting constraint. The fundamental limiting constraint is not that we don't want to improve, it's that we don't have the tools and the capability to improve. That's why this technology is so transformational. And you're seeing it in the demand curves for generative AI. Historically, we've been kind of a laggard. I mean, remember, like 15 years ago with the HITECH Act, the United States government literally had to bribe us and penalize us in order to get healthcare to adopt computers. Literally. It was unlike any other industry, right? Nobody had to go to shipping logistics providers and say, we are going to fine you if you don't use a computer in managing your logistics operation. But they had to do that in healthcare. Why? I would argue it was because that legacy technology was too brittle to be deeply useful in hypervariable healthcare deployments. And the magic of this technology is that it handles this enormous amount of unstructured data and variability in a way that legacy technology didn't. And you're seeing that in adoption curves. There's a great report out by a venture fund that showed that, it's almost hard to believe. It's like a 180-degree reversal wherein actually the sector that is adopting generative AI most rapidly is healthcare. And if you believe the numbers, we're adopting it at twice the rate of the sort of average across American industries. And so I think that you're seeing this pent-up demand because we have always had an incentive to improve care, if for no other reason than our professional ideals, in addition to the sort of tweaking around the edges around value-based payments and pay for performance. But we didn't really have the ability to, the technology didn't exist, and now it does. And so you're seeing this pent-up demand kind of explode in the uptake and the amount of spend.
One more quick question, and then I'll wrap up.
You talked about the complexity. So from a patient standpoint, a provider standpoint, and then across the cycle of care and our microcosm where we both operate in the operating room. And I'm wondering about your opinion as we implement these next future generations of AI and other technologies that can help us with that. is that there's some unintended consequences. So for us, in the work that we do in surgery, for instance, we might, for economy of scale, have like a surgical instrument set that works for the broad group, but on an individual basis, it's the wrong thing for the surgeon, and we have to adapt or we have to pull other things. So how do you look at this from a quality and safety standpoint? Are there unintended consequences of this where we're going to go down a pathway that makes it more inefficient, not efficient for that individual?
I think so. I mean, broadly, are there going to be unintended consequences? I mean, the answer has to be yes, right? So there are going to be new risks that exist that never existed in the past. I mean, to take something like very, very simplistically, as we automate processes, right? An individual provider can make a mistake, 5 or 10 times a day. An autonomous or a semi-autonomous system can make a mistake 15 or 20,000 times a day. And so there are going to be these novel risks that I think get injected into the system. And we've spent decades trying to understand human psychology and the way that humans perform within complex systems, and then designing systems to insulate patients from latent defects in human performance. And we are going to have to redo that for generative AI. We are going to have to create an understanding of this new intelligence and the latent defects in this non-human intelligence. And we are going to have to then do the work of designing systems that absorb those defects and mitigate harm to patients. And so I think that work will absolutely have to happen. But the second part of your question is around this sort of ability to be hyper nuanced and kind of in the way that we deliver care. And I think actually that's a strength of the technology. Your example of sort of, hey, here's the preference card, right? And we've got one preference card and this is just the way that we do it. That's an example of kind of a brittle algorithm, if you will, right? You have any one of these 15 surgeries, here's the instrument set that you're getting. And what this technology is going to allow us to do, I think, is to be able to reason over a lot more unstructured data with a lot more nuance. Your ideal state would be to have somebody who knows the operation that you're going to do, manually pick out every instrument that you think that you're going to use based on your historical performance of that operation. And that's not economically viable in the current state, but it probably will be when that cognition that it would require to do that type of predictive planning costs a few cents. And I think that's the future state that we're entering into.
Go back to the previous slide. So since I got to introduce Peter, I also get to wrap things up. And instead of a question, I want to end with a statement, because I love this slide at the bottom, because what it clearly suggests to me is that we're one level above a grassroots effort to accomplish the goals that you've been describing with all of these great institutes that we have, and I'm sure there are more that would be involved. But I don't think that's enough. I think that there has to be something bold at the university level to coordinate this so that we really accomplish all of these goals.
And health system level.
Thank you. Yes. So with that, thank you, Peter.